Hello students, let's do our conservation of energy problem, and we're going to call this one option 2. It's actually much simpler in terms of its fewer steps than option 1 if you watch that video. We still want to draw our before and after picture so that we keep track of all the information. So we've got a 2 kilogram car, right, and this car is moving along the floor with an initial velocity of 1.5 meters per second. And then our car goes up a hill or ramp or something like that. And it's still 2 kilograms. But now it stops. So our final velocity here is 0. And we want to find out what this final height is going to be equal to. We're going to make the assumption down here that our initial height is 0 because we're starting on the floor. Right? And here's our before picture. And here's our after picture. And we know that the energy on the before side must equal the energy on the after side. So we only have 2 different forms of energy for these types of problems, at least currently. So we've got kinetic energy, initial, plus potential energy, initial. And that must be equal to kinetic energy, final, plus potential energy, final. And then what we do is we take a look at our picture to see if there's any of these that I can get rid of. Well, there is, right? If our initial height is 0, then we don't have any gravitational potential energy because we need to have height in order to do that. On our after side, our final velocity is 0. So that means our kinetic energy is 0 because we need to be moving in order to have kinetic energy. We'll then take our 2 equations, right? If I've got left over here, I've got kinetic energy initial equals potential energy final. I can set the 2 equations equal to one another. Remember, kinetic energy is 1/2 mv squared. This will be for my initial speed, equals potential energy, right? This is gravitational potential energy, equals mgh. That will be for final. And all that I have to do now is solve this for h final. One of the things that you may notice, though, is that I've got mass over here and over here. These masses are going to cancel. So using conservation of energy can very often simplify a problem, right? Left over here, I'll just write one more step before we do our solve. 1/2 vi squared equals gh final. All that I need to do now is solve this for h final, and then I'm done. So h final equals vi squared over 2g. That's it. This is all we need to do to solve for our final height. If we put the numbers in now, we've got our 1.5 meters per second. We have to square that. Divided by 2 times our 9.8 meters per second squared. That's gravity's acceleration on Earth. Hey, if you're a new Martian rover, Perseverance, then it's going to be 3.7. Anyway, so our 1.5 squared divided by 2 times 9.8, we get 0.11 meters. So that's how we do these problems. I can tell you, if you have a choice in the future and you can turn your problem into a conservation of energy problem, I would recommend doing that because they simplify and make the problems a lot easier than almost any other technique that we're going to do. So there you have it, and I will see you in class.